Welcome to my video on solving one-step inequalities with multiplication and division. So solving one-step multiplication and division inequalities are similar to solving one-step equations. Notice the similarities. First, we isolate the variable. To undo a multiplication inequality, we must divide. So here's an example. 8y is greater than or equal to 24. What would we do to both sides? Good. Divide both sides by 8. And to undo a division inequality, we must multiply. And now what would we do to solve n divided by 4 is less than 7? Good, we'd multiply both sides by 4. Okay, and remember the golden rule of algebra. What I do to one side, I must do to the other. Okay, now we're going to try some practice, and the key is to remember to keep the variable positive. So let's look at number 1. Is the variable positive? It sure is. So what's the opposite of division? Good, multiplication. So we're going to multiply both sides by 3. What happens to the 3's? They cancel. Bring down the letter. Bring down the symbol. And negative 6 times 3 is negative 18. Now, remember in our previous notes, if you don't see this as a choice, then read it backwards. So it would read negative 18 is greater than or equal to n. Okay, number 2. 4x is less than negative 32. What's the opposite of multiplication? Good, division. So we're going to divide both sides by 4. 4 divided by 4 is a 1 in disguise. So we have x is less than negative 32 divided by 4 is negative 8. X is less than negative 8. Now remember, if that choice wasn't there, we'd read it backwards. Negative 8 is greater than x. Now, remember we said keep the variable positive. Well, now we have a negative variable. So I would like to show you, so I'm going to go back to a algebra tile screen here. And remember when we had this, okay? Our goal was to keep the variable positive. Okay, so let's use this example. We have negative x equals positive 2. Okay, remember when we did the ones with negative x's, we wanted to cancel out the negative x because we want a positive x. So what did we do to both sides? We brought over a positive x to that side and to this side. And what happened to these? Good, they canceled. And notice x plus negative x equals 0. So remember that in the future. Then we still didn't have the x by itself, so we had to put 2 negatives on this side and watch them cancel. And we had to put them on this side. So negative 2 would equal x. Now, I want you to remember what we started with there. So we started with negative x equals 2. And then I canceled out this, and I canceled out this, and look what it became. Negative 2 equals x. So when I moved this x over to this side, it became positive. When I moved the 2 to this side, it became negative. So I want you to remember this transition. because this is what's going to happen when the variable is negative. Okay, so now let's go back to our notes and try to tackle the remaining problems. So we have negative 3x is greater than 21. So remember, we wanted to move this to this side. So watch what I'm going to do. I'm going to add 3x because if I want to move it to the opposite side, I'm going to do the opposite. Okay, so my goal here is not to cancel out the negative 3, but rather move it to the other side. So this is going to equal 0. The symbol is going to stay the same, and I'm going to write down 21 plus 3x. Okay, now I'm going to want to cancel out the 21, so I'm going to subtract 21 because I want to get the variable by itself. The 21's cancel, and 0 minus 21 is negative 21 is greater than 3x. And now my last step, to get the variable by itself, divide by 3. 3 divided by 3 is a 1 in disguise, and negative 21 divided by 3 is negative 7 is greater than x, or I can read it from the letter and x is less than negative 7. Now, some of you are saying, well, Mr. Rennie, why don't you just divide by negative 3 and divide by negative 3? Well, look, our answer ended up x is less than negative 7. Look where it's going in the beginning, greater than. So most people wouldn't know to or remember to flip the sign, so that's why all we have to remember is get the variable positive. Okay, so let's look at another one. Okay, we have a negative 3x, so we're going to keep the variable positive by adding 3x. Okay, these cancel, and I get 0 is greater than 15 plus 3x. Now remember what I did in the last one. I got to get the variable by itself, so get rid of this 15. The 15's cancel. 0 minus 15 is negative 15 is greater than 3x. And then I divide by 3. Divide by 3. 3 divided by 3 is a 1 in disguise. And negative 15 divided by 3 is negative 5 is greater than x. Or, if I read it from the letter, x is less than negative 5. Now look, in comparison, look, once again it was going greater than, and now it's going less than. So let's talk about this for a second, because I'm also going to see if you see something as well. Now, first of all, why is the symbol flipping? Well, when the variable is negative, think about it. If you divide or multiply by a negative, so you don't have to write this down, just look at this. 3 is greater than 2. Is that true? Yes. But if I multiply both sides by negative 1, is that true? No. Negative 3 is not greater than negative 2, but how would I make it true? I would flip the sign. And that is why we flip the sign in these cases when the variable is negative, because whenever we're multiplying or dividing both sides by a negative, it's going to make a difference. Okay, I can multiply or divide both sides by a positive, and it's not going to change it. It's still going to be, this side will still be greater than that side, but as soon as I multiply or divide both sides by a negative, it changes its value, and then I need to flip it. So before we do any more examples with negative x's, do you see a shortcut that we could do here? Okay, and to point out the shortcut, you don't have to write this down. I want you to look at this for a second. Okay, that's what we started with. And when we get down to our final step, look what we have. And let me do it with this one as well. Negative 3x is greater than 15. That's what I started with. And when we get down to our last step, look what we got. So I want you to study these. Do you see what happened? I moved it over, became its opposite. I moved this over here, became its opposite. Move this over here, became its opposite. Move this over here, became its opposite. So you can avoid all these steps if you can remember to make the variable positive by moving it to the right and move the number to the left and make it its opposite. Okay, so let's try some more examples here. So let's try it on this one. We have negative x over 4 is less than or equal to 9. So we want to move this over here, and we want to move this over here. And remember, they both become its opposites. So the 9 comes over here, and I make it negative. The x divided by 4 comes over here, and I make it positive. So then I save myself some work. Now, this is easy. What's the opposite of division? Multiplication, so I'm going to multiply both sides by 4. What is 4 times negative 9? Negative 36 is less than or equal to. This becomes an x in disguise or 1 in disguise. And remember, read it from the letter to make it easier to graph. And x is greater than or equal to negative 36. Okay, let's try one more. Now this one's going to come over here, so it's going to become positive. And this one's going to come over here, so it's going to be positive. So notice I'm not always making the number negative like I did in the other 3 examples, but this time it becomes positive. Okay, now, what's the opposite of multiplication? Division. These cancel. 96 divided by 12 is 8, so 8 is greater than x, or x is less than 8. Now, I would strongly encourage you to pause the video at this point and try the next 4 on your own. Okay, welcome back. Hopefully you paused the video so that you can see how you did on these. So let's see how you did. The opposite of multiplication is division, and since this is positive, I don't have to move it. So divide both sides by positive 5. 5 divided by 5 is a 1 in disguise, so x is less than or equal to 7. There's my answer. Okay, number 2. The variable is negative. So remember, these two switch spots and they become its opposite. So negative 36 is less than positive 4x. Now I'm good to go. Divide, divide. 1 in disguise. Negative 36 divided by 4 is negative 9, so negative 9 is less than x. Or read it from the letter, x is greater than negative 9. Now look at our final answer, x is greater than negative 9. Look, the symbol flipped. Okay, and that's because the variable is negative. That will always happen when the variable is negative. Okay, 1/3 x is greater than or equal to 14. How do I cancel out a fraction? Good, multiplicative inverse or reciprocal. So the 1/3 times 3 is a 1 in disguise, so x is greater than or equal to 42. Okay, my variable's on the left, so I'll just leave it. Okay, notice here the symbol didn't flip because the variable wasn't negative. Okay, negative x divided by 2 is less than 16. Now I have a negative variable, so I'm going to switch spots. This 16 is going to come over here and become negative. This is going to come over here and become positive. Okay, the opposite of division is multiplication. So we're going to multiply both sides by 2. 1 in disguise on this side, and 2 times negative 16 is negative 32 is less than x. Or read it from the letter, x is greater than negative 32. Now, look, once again, the symbol flipped around. Why? Because the variable was negative. Okay, that concludes our notes on solving one-step multiplication, division, inequalities. I hope you have a great day.